Hey, what's up, folks? How's it going? This is Avijit here, and welcome to DevOps Challenge Hub. So let's start with today's interview question. Today also we have a couple of questions from uh, ECS. So today's first question is explain auto-scaling concept along with task scaling and EC2 scaling. So there, we have the concept of task scaling and EC2 scaling. Both are different. So how is it? How they're related? That we'll discuss, and that is the interview question. So for auto scaling, there are simple steps like turn on the auto scaling in for your ECS service and set a rule that if it is more than 60%, then you increase CPU usage more than 60%, then increase the number of tasks. Pick a metric to watch and CPU or custom cloud metric you can check, and attach the scaling policy, target tracking, and ECS will now automatically add or remove tasks based on the load. So here concept is a load distribution. Let's say it's a restaurant and there are like one shape is there and there are 100 orders coming. So these guys are too busy actually, right? Very stressed, safe, so high CPU. And now if there are like four shapes, so 25 orders, like total 100 orders are coming, it's getting distributed, load is getting distributed. So relaxed shape, like only 25 order they're handling, right? Low CPU. So ECS autoscaling works the same way. It adds more shape or task to reduce the workload task. Okay. And here we also have the concept. So this is the related with the task, and this task are running inside the, let's say, EC2. If it is a forget, that's a different concept. That will be handled differently. But in the EC2 instance, let's say there can be maximum three tasks. So if you are tossing three, more than three, then you need to add more instances. For example, let's say one shape is handling 100 orders, and then you see that it's more than 60%. So you added two shape. Now it's 50%. So it's fine. And now there are like more requests are coming. There are 1,000 orders. So in one restaurant itself, you cannot have 10 shifts because you don't have that much space and for cooking, etc. Right? So you need to add more building, more infrastructure, now more restaurants. So you need to add more restaurants. So that is the concept of is adding more EC2 instances, so that you can add more shifts or add more running task. All right. So task scaling and EC2 infrastructure scaling. So both are different that way. And for if you are using Fargate, AWS Fargate, it's a serverless compute engine. So you don't need to bother about infrastructure. Automatically, as the task scales, automatically Amazon also will increase the Fargate container. Okay. So let's see this example e-commerce website, and it's a service online shopping website, and there are two containers running, and target CPU is like a we want to maintain around 60%, and minimum task 2 and maximum we can run 8. So initially it's processing 500 requests, so 85% CPU. Task 2 also 500 requests per minute, 85% CPU. So average is more than average. Average we wanted 60%. So CPU usage by each task is very high. So we need to add more task. If we then it will be distributed. So then CPU is too high. Need to add more tasks to share the load. Now we added two more tasks. So like each guy is using 45%. Let's say 45% of CPU. We are happy that okay, it's below our average, whatever our target. And so this is what happening after scaling. Now let's say nighttime, it's like only like a 25% CPU, 75% request per minute or something, or less than that. And let's say like our target is maybe 40%. If it is a 40%, we'll scale down. Let's say like a 40%. If it is a 40%, we want to scale down. So since it's 25%, so it's underutilized. So we want to remove two tasks, so that it will be like again back to kind of a normal 50%, 50%. So it will be like about 40% and below 60%. So CPU is too low. We need to we have too many tasks for this workload, so we'll remove some tasks. So and here the thing is, and we won't do immediately. We will wait for 5 minutes. Like for example, there is a lunch rush hour. A lot of people are coming for lunch and placing order. And now it came down, let's say, instead of 20 orders per minute, now it came down to only 2, 3. But we want to wait for 10, 15 minutes before sending the ships back home. Additional extra hands we don't need. Only like after 10, 15 minutes also, it's just a 2 part minute. But again, after 10 minutes, again, 20 people keep coming. Then again, we will be needing those people. So that's why we need to wait for some time, 5, 10 minutes, and then we'll be reducing it. So that is also there, cool down period. Okay. And yeah, I think these are the things why we need a cool down period. It needed to prevent thrashing, rapid scaling up and down. Otherwise, like immediately if we see like it's 60% to came down to 40%, immediately we start shut it down. And again, means load goes up. Again, then we start going up. So it will go up and down, up and down. So we need to wait. Cool down period should be there, like 5, 10 minutes. We'll wait whether it's whether the rush hour is really over, right? Rush hour is really over. So that's why a cool down period is required. So rapid scaling up and down we can avoid. We'll wait for 5, 10 minutes. Then only after that, if for 10 minutes load is very high, then only we are going to add. If 10 minutes load is very low, like 10%, 20%, then only we are going to remove some tasks. So key takeaways are auto scaling. Auto scaling is mainly for load distribution. More tasks share the same workload. Metrics are averages. ECS looks at average CPU across all tasks. Application design will matter. Application should be able to handle distributed load, distribution of task and all this. And Fargate is a simpler. AWS manages the infrastructure for you. For EC2, it's automatically scaling up. But Fargate means like EC2, you have to add the infrastructure either through auto scaling or manually, whatever. But Fargate automatically AWS will do it for you. ECS needs two layering. One is a task scaling, other one is the instance scaling. Like number of shapes you want to add, and after some point of time, in one restaurant you cannot have 20 shapes. So you need to add more students. So you need to add more instances or more EC2 instances. So task is your shape, and instance is your kind of restaurant. And cooldown period prevent chaos. So what is ECS cluster autoscaling? ECS cluster autoscaling is nothing but EC2 for its applicable for EC2 launch time. Where EC2, you are going to scale EC2. You are going to add more restaurants. So let's say one EC2 can run 3 tasks maximum, or one restaurant can have maximum 3 shifts. Beyond that, you cannot add the capacity because there is no capacity, no space to cook. Similarly, no space to run more tasks. So you need to add more instances. So that EC2 cluster autoscaling is you are scaling up EC2 using autoscaling group. Capacity providers linked to autoscaling group. So this is called cluster autoscaling ECS. So if you have to look at the kind of that's where we discussed this one: EC2 scaling, task scaling, Fargate scaling. Right? Fargate automatically scales up. EC2 either through ASG or manually can scale, and task scaling also like maybe with the cloud metrics it will scale up. So if you have to like kind of mental model is like EC2 scaling is adding more restaurants, infrastructure EC2 scaling. Task scaling is adding more shifts in the existing infrastructure. And Fargate scaling will be like adding more shifts, but AWS manages the restaurant. So you are able to add more and more shifts, like more tasks you are able to add without bothering about the restaurants, because AWS is keep adding the restaurants, so you don't need to bother anything. Okay. Next question is, what are the differences, different ECS scheduling and placement strategies? So placement strategy, like we decide on the placement strategy, like to reduce the cost and high availability, etc. So let's say like if we want high availability, we have two institutions running in two different availability zones. One task is running here, another task is running here. But one EC2 can run 2 tasks, 3 tasks, right? Maximum 3 tasks, let's say it can run. So if you don't want high availability, we can shut this down and keep only one EC2 instance and run 3 tasks, right? So that's kind of task placement strategy. EC2 only, it's applied for EC2 only. Bin pack. Packs task on instance using least available CPU memory optimized for cost efficiency, bin pack. spread task across availability zone or instance ID. You are spreading it across availability zone. One task here, one task there. But if you want to reduce cost, all the tasks in the one EC2 instance. And random places task randomly. So bean pack, spread, and random, we are the placement strategy. So like scheduler, there are two types of scheduler. Service scheduler is for long running app. For long running app like web service or web API. It's a long running. Always that has to be there. The task will be running because someone can call it anytime or that someone can visit your server anytime. So that's a long running thing. So here you have service type like replica. Replica means you run minimum number of specified tasks. Like let's say I'm running minimum two or four web servers. Okay, that is the minimum I will maintain. That's a replica. Automatically replaces failed or stopped task. If it crashes 4 to 3, again it will replace and it will become 4. So it's based for stateless apps, APIs, and web server. So this is the replica type. Other one is a daemon. Daemon is one task for one EC2 instance. So you have 3 EC2 instances. So you need one for one instance. Why? Because you may want to have logging. So logging task here, logging there in the 3 EC2 instance. Or agent. Agent should be there in every EC2 instance. One, right? One task per EC2 instance. Daemon is one task per EC2 instance. And replica is like minimum number of tasks. And task placement strategy we discussed, like bin pack is like all are packed into one bin or one area, and spread you're distributed for availability. And random you're randomly pressing this. Then second one is a task scheduler for one-time jobs. One-time jobs, like you don't need to run like web server API for long. Like one time some task comes, you want to convert some video file from one format to another format, or if you want to zip a file, you are providing zip providing service. So it's a one time. Request comes, you subset does it. So it's a one time run manually. You can run it, or through event bridge scheduler automated. You can do that. Cron job kind of thing, recurring task can run it. Run and stop it on its own. So this is also possible. And or you can trigger this task automatically using some script or trigger. Okay, so let's go to the quiz section. You can pause the video and you can try to answer on your own. Which of the following is the easiest way to configure ECS autoscaling? Scaling it to manual target policy, cloud metrics. Target tracking policy using cloud metrics. This is the easiest way to autoscale. Target tracking with cloud metrics. Which launch type supports ECS cluster autoscaling? Cluster autoscaling, which one supports? Only EC2 supports that. EC2 only supports that cluster autoscaling. What is the difference between ECS task scaling and EC2 scaling? ECS task scaling and EC2 scaling differ. Task scaling changes the number of containers, and EC2 scaling changes number of servers, right? So task scaling changes the number of containers running inside one EC2, right? Like number of shapes, right? Task container, it's actually with the container. Task is container, or you can like analogy wise, you can think it's a number of shapes in a restaurant, and restaurant is like a EC2. So task scaling changes the number of containers. EC2 scaling changes the number of servers. Answer is B. Which ECS scheduling strategy ensure one task run per EC2 instance? It's a daemon. One task per instance. Like for example, logging ECS agent. Right? You need one task per instance. Logging every instance you need to log, right? So you need one task per instance. Okay, so that's it for today. Hope you like this video. Please like, share, and subscribe to my YouTube channel, and also follow my Devops channel page. I post quiz content daily. You can participate in that, and you can also follow my WhatsApp channel. I post regular updates there. Thank you for watching this video. See you again in the next video.